Hello, students. Let's do another example of factoring a quadratic using algebra tiles. In this example, we'll use 4x squared plus 7x plus 3. So once again, we go to our technology.cpm.org/general/tiles website, and we click on backgrounds, click on corner piece to arrange our screen area where we will do our factoring. We show our Algebra Tiles page, and we proceed to drag and drop 4 of the x squareds, 7 of the x's, and 3 of the 1's. Let's do that. 1, 2, 3, 4 of the x squared. We need 7 of the x's. 1 and 2 and 3 and 4 and 5 and 6 and 7. And we need 3 of the unit tiles, 1 and 2 and 3. So as before, with algebra tiles, you have to arrange the area objects into a rectangle. So we want to take all this stuff here, every bit of it, and put it into a rectangle. Give it a rectangular shape. So I'm just going to move some stuff around to give myself a little breathing room. And you can move these objects around in any way you wish. And you might want to speed up this portion of the video if I'm doing it too slowly. You typically put the x squared object in the lower left-hand corner. And I have not factored this one. So it could take me a little bit of time to figure out how to factor this one. So what do I got here? Can I make a rectangle out of this stuff? How am I going to do a rectangle here? Well, if I double click on these objects, they'll rotate. That's kind of cool. Could I put this here and this here? And I can put this here and this here. So I got a rectangle, but I screwed up. I got 2 extra pieces here. Not cool, Mr. M. So how are we going to deal with that? Let me move this around and put it here maybe. Something tells me I'm going to need to have like 3 spots here like that. But now I'm short one of these things. Can I take this out of here like that maybe? But now it's kind of weird because I got this extra blank spot here. Could I move this like that and that like that? Could I then move this around like that? Well, that's not going to work. That ain't going to work. How about if I just move this all down here? Move these out of the way. Oops. Move all 3 of these out of the way. How about if I just put them on top like this? Can I move this like that? That's not going to work. How about if I move this like this? And this like... That's not going to work. That's definitely not a rectangle. So it takes a little bit of time, as you can see. It's not all like 100% no-brainer for how to arrange your algebra tiles. So can I do something like this? I got 3 of these. Can I rotate that and put it there, and rotate that and put it there? Can I move this like here? Can I put that like that? Well, that's close. Can I move this over here? I keep on getting close here, but no cigar. And I can't just put another x here because that will create something that is not 4x squared plus 7x plus 3. I got 4x squared plus 7x plus 3 here, but it's not a rectangle. It's still not a rectangle. Woe is me. What will I do? Well, I keep trying. So I'm going to try this. What if I move all this stuff like here? Put all this stuff right there. Put all this stuff right there. Nope. Still don't got it. How about if I make all these vertical? All of them vertical. And I'll put them all like here. And I'll make this one vertical. I'll make that one vertical. I'll make that one vertical. Could I put all 3 of these here? Ooh, super close. Ouch. That makes this hurt all the more because I don't have exactly 3 here. Okay, I'm hoping some of you can see the way out of this mess. You're going to help me out here? How am I going to get out of this mess? Well, I can put 2 of these here. Oh, that's working. Now I've got this extra turkey right here. Oh, I'm super close. I just need one more of these things. So I'll try to move this one there, and that's cool, but I'm missing something here. Ooh, could I do all this and move this all out of the way? Like that, maybe? Move it all here? Could I put this one here? Oh, that's super close. Dang. Really close. All right, move this down back there. Take this all and move over to the left. That's not going to work. How about take this out of the way and put that there? That's still not going to work. What if I put this all like this? Oh, these are not the same height. All right, I'm going to put them all in a long row. And what about this one here and that one here and that one here and that one here? Did I just get lucky? Oh my goodness, I got lucky. I made a rectangle. Mock victory. Hands raised in mock victory. Okay, that was tricky. Okie doke. So we've done the factoring using algebra tiles. And you're probably thinking, and correctly, might I add, that this is obviously not a very practical way. This is not a practical way at all to work with quadratics. However, it is a way to visualize quadratics, and some people factor quadratics way easier using this method. So keep this as just another method in your toolbox, another way to imagine the geometric visualization of a quadratic. All these pieces together in the middle, 4x squared, 7x plus 3, wind up being equal to 4x squared plus 7x plus 3. This is an area. This is the area of a rectangular object that has certain dimensions. Now let's take a look at those dimensions. How wide is this? And how wide is that? And how wide is that, and that, and that, and that, and that, in terms of the length? Now, in terms of the width, how wide is that, and how wide is that? Well, I think this is a width of x, and this is a width of x, and this is a width of x, and that's a width of x. This is a width of 1, and that's a width of 1, and that's a width of 1. This is also a width of x, and this is also a width of 1. When you add up all those individual lengths and those individual widths and combine them together, you have the length and the width of the overall rectangular object. So there's 4 x's here. So 4x, and we have 3 ones, plus 3. So that's one of our factors. Along the vertical axis here, we have x plus 1. I'm going to erase this arrow here because it's getting in the way of my drawing. And I'll draw the arrow like that. So we have x plus 1. That's our other factor. So the length here and the width corresponds here to length times width, which, as you know, is equal to area. That's another reason why we speak about algebra tiles, because they're a convenient way to connect the length of an object, the width of an object, the geometric visualization of the object with a symbolic object. This is a collection of symbols. When you look at it, you see a 4, you see an x, you see a little 2 up at the top, you see a 7, you see an x, you see a 3, you see some pluses. You don't necessarily immediately see this geometric object behind all those symbols. But algebra tiles gives you the ability to see that geometric object. Now, if I were to multiply 4x plus 3 times x plus 1, what would that look like? Well, let's do it up here. So 4x plus 3, let's multiply that by x plus 1. So we're going to do the distributive property here. Sometimes it's called FOIL, first, outer, inner, last. But if you multiply two things, you multiply each thing by every other thing. So 4x times x plus 1 plus 3 times x plus 1. So you write that this way, 4x times x plus 1 plus 3 times x plus 1. Just the distributive property done twice. So 4x times x is 4x squared. 4x plus 1 is 4x. 3 times x is 3x. Should put a plus there. And 3 times 1 is 3. And when you add all those terms together, you get, drum roll please, 4x squared plus 7x plus 3, which is exactly the object that the quadratic symbolic object that we started out with, 4x squared plus 7x plus 3. So we came up with like a geometric way to come up with the factors. And the factors of 4x squared plus 7x plus 3 are 4x plus 3 and x plus 1. And this right here is not at all visible, just like immediately, when you look at 4x squared plus 7x plus 3. But behind 4x squared plus 7x plus 3, there's this 4x plus 3 and x plus 1. And algebra tiles are a way to bring that forward, to make those hidden factors visible. For example, if I give you the number 6, you kind of know what the hidden factors are. They're 3 times 2. You also know that 1 times 6 is a way to factor that number 6. So you can kind of see the 3 times 2 much faster with the number 6. But with the number 4x squared plus 7x plus 3, it takes a little bit of effort to see that 4x plus 3 and that x plus 1 as the two factors that will, that when multiplied together will produce 4x squared plus 7x plus 3. So that's another example of using algebra tiles to factor a quadratic.